Standard deviation and variance, not the long way. Okay? If you have 20 or less points of data, I'm going to make you do it the way we've been doing it with a table. If you have more than 20 points of data, you'll be able to use technology. Okay? And I will let you know on the test which ones you're allowed to calculate without showing the work. Okay? So first of all, let's see. We have 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 36 data points. Okay, and yes, we could make a table and calculate this all out the long way. But what we're going to do instead is we're going to use a TI calculator, TI-30. I'll give you the directions for TI-30. I will give you the directions for the Desmos calculator. And I will give you the directions for the online, there we go, standard deviation calculator, okay? So the first thing we need to do is look at the TI-30X. We had that big long list of data, which I have here on this extra sheet of paper, so we're going to go over that. Remember, it had 36 data points. All right, so to enter it into a TI, one of these calculators, which you can use in class, to buy one is about $20. We want to first go to this button where it says data. And we have this table, and now I have old data in here, so to clear it out you have to press delete. And you have to delete each line individually. Or, actually that's not true, you could have pressed data again and then you select to clear. Alright, so what you want to do is you put the numbers in, and after each number you press enter. So 54, enter, and it puts it on the first line. And I'm going to go ahead and continue to enter these, and I'm going to pause the video while I do that so that people entered all 36 numbers. I'm going to turn the light off again for a second so you can see the buttons better. I hit second function, stat. See how there's stat over top of the data? And it brings me to this screen that says one variable stat, two variable stats. I want one variable stats because I only have one list, right? So I press enter, L1, 1, enter, enter, calculate. You just, once you've hit the one variable statistics, you just enter 3 times. Press enter 3 times. Now, what it brings up, n equals 36. Now, if you are using this calculator and you're writing this stuff down for like a homework assignment or the test, what I would want you to write down is this information. So let's see, this is example A. So I would write n equals 36. Scooch these over a little. I would go ahead and write down, okay, now Sx. This is standard deviation of a sample. Okay. If I scroll down one more, I get this one, which is standard deviation of a population. Depending on what problem I have, depends on which number I need, and you can see they are different, 14.28 versus 14.08. No, you actually write down the number. I'm just showing you that Sx is for sample and sigma x is for population. Now, this problem that we were working on says it is for a small population. All right? No, population is sigma. So population is sigma, so this is the one we want. So it is 14.087, or you could say 14.1 Or you could say 14.09. Or 14.3, yeah. Yeah, exactly. Okay, so that's our standard deviation on a TI-30. Okay, any questions on that? All right, on the Desmos app, under functions. I know, there's nothing I can do. If I turn this off, it's even worse. See? I'll try. Okay. All right, so on the Desmos app, guys, I hit functions. I hit stats. Do you see how it says standard deviation and standard deviation P next to each other? Right here, stdev and stdev P. Sample, population. You have to choose the correct one or you're going to get the wrong answer because it doesn't give you both at the end. It only gives you one or the other. So we're at a population, so you click that. And then you enter all of the numbers with a comma in between them. Okay, I am not going to enter all of the numbers again because we've already seen how this works. But you see what I'm doing? I'm just entering the numbers with a comma, and every number I add changes. It's constantly calculating the standard deviation. So you gotta put the comma in? You have to put the comma in because if you don't put a comma in, it's going to be, what is that? 54,926,064. And there's no standard deviation of just one number. So you have to put commas in between every number, okay? And I can download this on my laptop, right? No. No, you download this to, it can go on a iPhone. Well, it might actually go to a laptop. Check. Google it. I'm not really sure. I know you can put it on iPhones and Android phones and iPads and tablets. I'm not 100% certain on a laptop. Okay, so any questions, guys? Any questions on how to enter this into Desmos? Finishing example A. So now we know that the average bowling score was 63.7. Is that what I got? 63.6 repeating. Okay, so 63.7 and the standard deviation was 14.1. So we can put that into a normal distribution curve. So remember our normal curve. We have a straight line on the bottom and a perfect curve on the top. See my straight line and my perfect curve? The mean is in the middle, which was the 63.7. And our standard deviation is 14.1. So we have to add 14.1 3 times. And our first one is 77.8. Add 14.1, I get 91.9. And then add 14.1 and I get 106. Then I go back and I subtract 14.1 and I get 49.6. And I subtract 14.1 and I get 35.5. And I subtract 14.1 and I get 21.4. Now remember, 68% of our data is between these two numbers on either side of the mean. And then 2 standard deviations over gives us 95% of our data. And then lastly, 3 standard deviations give us the 99.7% of our data. Okay, I keep stressing that because these 3 numbers are very important when you're talking standard deviations. Those are that's the rule. 68% of your data is within 1 standard deviation of the mean. 95% is within 2 standard deviations of the mean, and 99.7 is within 3 on a normal curve. Now, in reality, it might be slightly different because reality is not perfectly normal. But if since we assume normality, those are your percents. Okay, now we are already found the variance because we used the easy calculator online. But again, if we're using the TI, we already did this one, but remember our standard deviation was 14.1. So our variance is 14.1 squared if you're using the TI. And 14.1 squared is 198.81. Okay. If you use the online calculator, it'll just give it to you. So it depends on which calculator you're using as to whether you have to square the standard deviation or you just have the variance, okay? No, that's when you're calculating variance from a list of numbers. And you take the sum of that list and you divide it by how many numbers there are. But then, let me do another page real quick. So, variance is the sum of that list of numbers divided by n, or it's the sum of the list of numbers divided by n minus 1, right? Whether we have a population or a sample. Standard deviation,
The second one is sample, right?
yeah. Sample, population. And this one is squared and this one is s squared, okay? Now if we standard deviation is the square root of that, which is the same thing as saying the square root of the variance. That looks terrible. Yeah. Okay, that's squared, okay? Or again, if it's a population, and that's if it's a population. If it is a sample, there's a thing there, it's x minus x bar squared sum divided by n minus 1, which is also the square root of s squared. So the standard deviation is the square root of the variance. Well, if you're calculating from the list and going from the list to standard deviation and you're doing the calculations by hand, you calculate the variance first and take the square root of it.
Okay, so whenever you get there, basically you're just coming over there and adding things. Like how you have this s squared and then the
Here,
other thingy, the big that looks like the r. Okay, that's just whatever you get.
sigma.
The sigma, that's whatever you get in the e, x minus.
Yes.
That's whatever. Okay, I don't know how to say it.
You calculate the variance first, take the square root of it, you have standard deviation. Okay, now this is, like I said, this is if you have 20 items or less. This is like how we're going to do this.
Okay, so I already know how to do that then.
Yes, you already know how to do that. Now, if you have more than 20, you're going to use a calculator or the computer to calculate the standard deviation. So you enter the list, and then it's going to, generate the number, okay? Now, if you're using the calculator, it does not give you variance, okay? So the calculator gives you standard deviation only. So you take the standard deviation and you square it to get the variance. So you take what we had there was the 14.1 that came out of the calculator as our standard deviation, and I squared it and it gave me variance.
When we have the test tonight, when we get our laptops, can we use the calculator or?
We have laptops.
Okay.
Yeah. Yeah, you don't have to.
Worry about all that first.
No, we have laptops here. We're going to do this one on the computer. We have this long list. I have 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 36 numbers that I'm going to enter. So I'm going to go to the Easy Online Calculator website, and I'm going to start entering. Lost my place for a second. Okay, there I go. I entered all of my numbers. I click calculate. I entered too many numbers. Darn it. What'd I do? I think I entered the same row twice. Yep, I did. Look, see 55, 88, 88, 81. And there's again. So I'm going to delete those. And I'm going to calculate. See, that's how you can double check yourself on this too. You figure out how many numbers there are on your list first. And then when you check your total numbers, if it's off, you know you did something wrong. Okay, so for this particular group of tests, we're doing a small population, so I want these numbers. So my average was 80.86, so I'm going to say 80.9. My standard deviation is 12.1. And my variance is 146.3. If I had done this on the TI calculator, I would have taken 12.1 and I would have squared it. Okay?
And then the sigma squared.
That's variance. Yeah. Right. We might have to calculate the standard deviation of grouped data. Okay, so what does that mean? If I have, let's say some people are playing a game. Some students are playing a game and one of the score is 15 and 3 people got a 15. 6 people got an 18. 6 people got a 21. 8 people got a 23. 2 people got a 24. 5 people got a 27. 10 people got a 29. 6 people got a 32, and 2 people got a 28. Okay? So if I were to make this a big long list of numbers, I'd have 3 15, so it'd go 15, 15, 15, 18, 18, 18, 18, 18, 18, 21, 21, 21, you get the idea. There would be 6 21s and then 8 23s and then 2 24s and then 5 27s. So N is the sum of this row right here.
And then what?
The number of people.
That's just for
The number of numbers, because there's 3 15s, 6 18s, 6 21s. So if I add this row up, it tells me how many numbers would be in the total list. So when I add all these up, I have 3 plus 6 plus 6 plus 8 plus 2 plus 5 plus 10 plus 6 plus 2, 48. All right, now, you could, if you wanted to, go to your easy calculator and reset it and enter 15, 15, 15, 18, 18, 18, 18, 18, 6 times, and enter 21 6 times, and enter 23 8 times. You could do that. I'm not going to do that.
Okay, while you're doing that, is that for just when
The formula to calculate for grouped data. We calculate the variance. We have the sum of the frequencies of the x squareds divided by n minus the the average squared. Yes. F is the frequency. Okay, so frequency is how many times each number shows up. So 3, 6, 6, 8, 2, etc. X squared is the data. So 15 squared, 18 squared, 21 squared, 23 squared. N is your number of numbers, right?
data is okay.
This is your data up here, the scores. And then mu is your average score. From the top.
That's all the numbers added up together?
No. Well, it kind of, hold on. We have to talk about calculating the average. We did average from a frequency thing before, so we're going to talk about that again. So this is for variance, and then we're going to find the average first. We already know n. The next thing we have to find is the average score. So remember how to find the average of grouped data? We take 3 times 15 plus 6 times 18, because I have 6 18s, plus 6 times 21, plus 8 times 23, plus 2 times 24, plus 5 times 27, plus 10 times 29, plus 6 times 32, plus 2 times 28. And we divide all of that by n. This is the mean of the group data, yeah.
Okay, that's just for the mean, but for the
We haven't gotten to that point yet. We have to find the mean first, okay? So we have to find the mean first. So when I do all those numbers, I get 45, 108, 126. So what I'm going to do is I'm just going to cross these out and put what they equal so we can save space. See what I'm doing? Does that make sense? Is it okay? Right. Okay, and then when I add them all together, I'm going to get 1,184, and I divide that by 48, which gives me 24.7. Okay, actually it's 24.67, so let me write that down, because that's what I put in here. Okay, I need, if you look up here, I need that squared. So that's my next step. I'm going to take my average and I'm going to square it, which equals 608.61. So far, okay? So once I've done that, then I can go to this part over here, okay? So this part first, this part second. Yeah. Yeah, first you want to find the average, then we go on to the next thing. So I'm going to put a little line through here so you can see that that's two separate things happening right there. Okay, so 8 times 23 squared plus 2 times 24 squared plus 5 times 27 squared plus 10 times 29 squared plus 6 times 32 squared plus 2 times 28 squared. So this is all of these numbers times these numbers, but this number is being squared. So far, okay? Individual data has to be squared. So what this ends up being is 3 times 225 plus 6 times, I didn't do this individually on here, so let me, 18 squared, which is 324, plus 6 times 21 squared, which is 441, plus 8 times 23 squared, which is 529, plus 2 times 24 squared, plus 10 times 29 squared, 32 squared. Actually, I knew that one. 784. Okay. Then I multiply each of these individually. Now, my calculator, this calculator, will let me enter the 3 times 15 squared plus 6 times 18 squared plus, and give me the answer at the end. I didn't have to do this out like the long way, but I'm just going to write etc. right there because it gave me a total of 30,416. Okay, that's for this part. That's this green bit right here. Now I take, to find my variance, I take all of those numbers that I just calculated and I plug them in. So the e of fx squared was 30416. N, which we already had, was 48, minus that average squared, which was 608.61. So when I divide, I get 633.67 minus 608.61, which gives me an answer of 25.06 for my variance. So far, okay? And then my standard deviation is the square root of my variance, so it's the square root of 25.06, which makes it 5.01. Yes, I saw that, sorry. So again, you can do this two ways. You can either go online, because the TI won't take that many numbers. There were 48 of them. The TI will only take 42 numbers. So the TI will not, the 30s. Not everybody has one of yours. So the TI won't do this. No, that's what I'm saying. The TI, the calculator on the computer will probably take that many data points, but remember, if we're going to do this on the computer, you would do 15, 15, 15, 18, 1, 2, 3, 4, 5, 6. You see what I'm saying? So you have to be really careful that you get the right number of numbers in there. I think so, because I know that I'm not going to make a mistake on paper this way. Yeah. Whereas if I'm typing in multiple 21s and multiple 23s and stuff, I might type in the wrong number of numbers, which messes everything all the way up. And when you're doing a calculator problem like this, you're telling me I did it on the calculator and you're giving me an answer 6.7. There's no work. I can't give you partial credit.
But for the other ones that we just did.
But for this, I can give you partial credit. I can look at your work, and if you added wrong here or something.
I mean, for the standard deviations that we have to use on the computer, what we just went over for this, those you get full credit because you just write down what we did.
Yeah. Okay. Yeah, but like I said, there's no work. So if you got the wrong answers because you entered a button wrong, like you put 25 instead of 26 or something, I can't give partial credit because I don't see work. Yes, absolutely. But for these, if you're doing it this way, I can look, like, let's say 3 times 225 is 675, but you wrote 670.
That's too many numbers to write down. You said to use the calculator, right? For the
Yeah. You can do it the long way if you want to. You can always do it the long way if you want to. You probably just don't want to. I'm guessing. Okay, for homework tonight, pages 234 through 763. Just kidding. Sorry. No, I was kidding. Page 234 to 235, and then page 1 that follows. Odd problems, evens, of course, are extra credit as always.